Hello everyone, and welcome to Coding Corner. And today we are going to learn about plotting. But before that, what is plotting? It is a graphical representation of our datasets, and usually it learns the relationship between two or more variables. In this video, we are going to learn how to code this using Octave Online and learn tips that could make our plotting much easier and better. This video, we have three plotting techniques that we are going to use. First one is the linear plot, the semi-log plot, and the log-log plot. And this will be further discussed by our coders. And without further ado, let's go over to Mr. Fitz and tell us how this works.
So thank you, Paolo Gaviola, for that wonderful introduction. So now let's get to the procedure part of the group activity. In Octave Online, there are many functions that we needed to become familiarized in order to proceed. Most importantly, the functions used in plotting, as our topic is plotting. So for the functions in plotting, there are three types of plotting procedure. First is the regular plot, wherein both x and y axes are scaled linearly. Next is the semi-log y, wherein the y-axis is scaled in the power of 10, while the x-axis is scaled linearly. And lastly is the log-log, wherein both x and y are scaled in the powers of 10. There is also a function wherein we can force equal scaling of the x and the y-axis. So for the symbol, here are the symbol options of the plot. So after knowing the three types of plotting procedure, we will now proceed to the data of our plot. In setting up the data of our plot, we will be using two functions wherein it is named x dot and y dot. X dot is used for the data in the x-axis and y dot is used for the data in y-axis. And after the data is now labeling, we will need to label our x-axis, y-axis, and the title of our plot. So in labeling the x-axis, we will be using the function xLabel, parenthesis, xName, parenthesis, and for the y-axis, we will be using the function ylabel, parenthesis, yname, parenthesis, and then for the title of our plot, we will be using the function title, parenthesis, graph name. So let's get to the actual procedure where we are going to use the Octave Online. So for the procedure number 1, we are going to do a linear plot with a symbol of color blue and asterisk for the symbol using an x data of 1, 5, 10, 15, 20, 1, 5, 10, 15, 20, and y data of 0.12, 4, 16, 33, 61, 0.19, 3.2, 14, 37, and 58 with an x label of time, minimum, x label of mass, kilogram, and a title of agglomerated mass versus time. So doing it in Octave, this would be the result. And after that, we are going to save the script and then run it. So there it is, the plot of this data and y data. So that's it for procedure number 1. So for the next procedure, procedure number 2, we will create a function that is named linear plot that will output a result that is similar to number 1. And in procedure number 3, we will test it using this command line. So let's do the code in procedure number 2. Here is the code that I have come up in procedure number 2. So we are just going to save it and run it. Then after saving it, we will now use the linear plot function and test if it will work and show a result that is similar to number 1. So here is the code. I will now enter this, and there it is. The result is similar to the number 1 that we have before. So that's it for procedures 1 and 2 and 3. And now let's move on to procedure 4, 5, 6, 7 with Walter.
Continuing on, we have the procedure 4 using variable values instead of hardwired values. I have here a code. Set of code now for the procedure 4. I will use this code. Where data y data give it. And for the symbol, we have represent blue in at the table at the top and the type asterisk over here. And use the linear plot to determine the variable instead here. Now let's try to run. As you can see, this is the graph that this is the plot that have been shown. Now for the procedure 5, we are to choose our display information as given that given above, wherein the table have symbol color and symbol type. So let's try to see it here. Symbol color, let's put function. Symbol type has also input function. Now let's try to run the code. Now for the command window, we will pick a symbol color at the table. Now let's try grid and see 0 or letter O or circle. You can see here the display information will change. Now continuing on to the procedures, wherein we will use the semilog plot function, semilog plot as variable, and continuing on symbol color, symbol type, and while our plot that existed here, we have the semilog function. Let's try to run the code. Let's try to erase this. And continuing on, let's try blue for the color. And D for diamond. As can be seen here, we have different curve and a different display information. Continuing on to the figure 7, we have the log-log plot. It's the same for the semi-log plot, but instead of a log-log plot here, we will see differentiate what will be result. Let's try same for blue and diamond. As can be seen here, it's different. Instead of the curve like this, or the curve like this for the linear plot, we have the typical linear here. And that's all for the procedure 4 to 7. Now let's move on to the exercises where it will be explained by Peter.
Good afternoon, Tutor Lawrence de Corsino. I will be presenting the exercise section of the Activity 6 plotting. So firstly, the exercise, let's read our goals. So this create a script that will perform the following. Display a header message when first run, get plot information, ask the user to select what type of plot, display the requested plot, ask the user whether the plot is okay, and if not, cycle back to see for another plot, and repeat the previous cycle until the user is satisfied. So first I will talk about our plan for this. So for our plot information, this will be a simple call for inputs assigned to variables, and so will be the ask the user, but this will include a switch statement for whether which function for plotting will call. The display will be included in the function that will be called, and asking the user whether the plot is okay or not will again include an input statement and a switch for this goal. Then for the repeating cycle, our idea here is to make the entire code loop with a while loop. So let's go ahead and start adding those things. So firstly our input. So for the plot information, let's put a comment right here. Then assign variables, symbol 1, name 1, y name 1, and graph name 1. So as you can see here, we already have the variables for assigning, but before that, I already had here a free code. So what includes here is switch statements for the color choices and the symbol type choices that we have, and the functions that I previously talked about for linear plot, semilog, and log-log plotting. So now for symbol 1, will be a combination of symbol color and symbol choice. So easy as that. Then X name will be input. Make sure that the result will be a string. And just like the y-axis, for the graph name, it's the same thing. Now that we're done for the plot information, we're going to go ahead with the type of plotting. So for the plot, we'll input. Then we're going to do a switch statement. For case 1, it's linear. We're going to call linear plot function right here. Let's use this. And input data is required for the function. So as displayed here, the linear plot, x dot and y dot is our previously identified data from the previous exercises. Symbol 1 onwards is from the plot information that we will get from the input of our user. So on to the next case. It's going to be just a repeat again. Just call again a function just with a different name. Same goes for the third case. Now in case we input something that is not known, and just to keep the code going, we're going to have an otherwise statement right here. Input valid button instead of an error. And switch. Next is we need the confirmation whether we are satisfied or not with our plotting. So we're going to identify, we're going to put another input here, asking the question whether if we're satisfied or not. Another switch, case yes. I will go to explain what is MU. Here, we'll code first. Another otherwise, in case we get a undesirable response. Then we end switch here. So what is the new variable here? So the new variable here that is going to be the variable that I will assign for the while loop. So we're going to turn the entire code into a while loop. Let's put the code while loop. First we have to find the new again. While new is equal to 0. All of this up here will happen. So we'll put here and while. So basically it will happen here for satisfied. New will become 1. Thus the while loop will not satisfy the condition of whether new is equal to 0. Therefore the while loop will break. If we are not satisfied, the new will stay 0 and the entire code will repeat again. So now let us test our code. Let me start right here. Now we're asking what color. Let's try for the usual blue. Star. Name for an x-axis, call it axis x, call it axis y. Then a graph. So let's type of plotting, let's say linear. And we have a result, which I will display. Here we have graph right here, the command window for a bit. There we go. Are we satisfied with the plot? If we type yes, the loop will break. So let's try again. What if we're not satisfied? What if we want another color? Let's try magenta this time. Symbol, let's try diamond, this is x again, this is y, then a graph. Let's put a smiley face. What type of plotting? Let's try log, then we should have the result. Have it right here. We have a magenta plotting with the log plotting. So what if we're not satisfied? What if we want different color, another one? Let's say no. We're going to code again from top to bottom. Let's go yellow this time. Let's try star. Same name before. Graph. Let's try semi-log. Then we should change the result. As you can see here. Are satisfied with this type of plotting? Yes, I am. So going back again at our goals, we've displayed a header message when first run, showing that plotting. We can see it at the command window. That is called plotting a graph. Then they get the plot information. We've obtained what color, what symbol, name of x, y axis, and the graph name. Then we ask the user the type of plot that we want. We selected log, we selected semi-log, we selected linear. And then we displayed the requested plot as I presented here. And we ask the user whether the plot is okay or not. We answered both yes or no. If yes, we're going to break the loop. And if not, we're going to repeat it until we're satisfied. So we filled all our goals here. So that means our code is effective and is working well. And that ends my presentation for the exercise of activity 6. Thank you for watching.
And that's all for today's coding corner, guys, and hopefully you guys have learned something from it and have enjoyed watching the video. And make sure to use these skills to further improve your coding skills, because plotting is useful, especially for data that you want to grab. And let's thank our coders for giving us this knowledge. Let's thank Mr. Fritz, Mr. James, and Mr. Jeter for the knowledge that they have bestowed us today. And let's also thank our editor, Mr. John Joshua, for making this video so that you guys could also watch. And that's all for us, and thank you again for watching the video. And that's all from me, Paolo, and peace out, guys. Bye bye.